Hi, I'm going to conduct the experiment on the topic Young's double slit experiment using a laser light. The aim of this experiment is to investigate the Young's double slit experiment using a laser light. Some of the misconception here is light only double in a straight line. Light do not form a wave. Light can only be reflected from shiny surface. If I explain the theory on wave model for light, many scientists propose a wave theory of light based on the experimental observations, including Robert Hooke, Christian Huygens, and Leonhard Euler. However, Isaac Newton, who did many experimental investigations of light, had rejected the wave theory of light and developed his light is emitted from a luminous body in the form of tiny particles. This theory held influence until the beginning of the 19th century, despite the fact that many phenomena, including diffraction effect at edge or in narrow apertures, color in the thin film and insect wings, and the apparent failure of light particles to crash into one another when the two light beams cross, could not be adequately explained by the corpuscular theory. To conduct this experiment, some of the materials here is laser pointer, scissor, electrical tape, thin wire, paper with two holes. Before we conduct this experiment, some of the conditions should be considered. The two sources should emit continuously wave of same wavelength or frequency. The amplitude of the two waves should be either or nearly equal. The source should be narrow. The source should be close to each other. The two sources should be coherent one. In procedure, firstly, cut two small strips of electric tape and place them over the laser pointer, laser pointing, leaving relatively small gap. Second, shine the laser on the white surface and notice what the dot look like. Next, carefully place the small strand of wire across the opening of the laser and hold its end by placing piece of tape. Make sure to keep the wire as straight as possible. Now, carefully place two pieces of tape on either side of the wire over the opening, getting the tape as close as you can on the wire without touching it. It might take a several attempts to get the perfect one. Turn off all the light and shine the laser on the white surface and notice the difference between previous one and the present. As a result, we can observe that number of vertical lines are observed over the single dot, diminishing brightness further away as they go from the center. From here, we can conclude that the number of interference pattern depends upon a number of factors. Number one is the nature of source of light. In here, there are two types of source. Number one is monochromatic source. If the source emits a single wavelength of light, the interference pattern shall consist of black and white fringes. White light source. In this case, the pattern consists of color fringe. The center fringe shall be black fringe surrounded by a color fringe on either side. Width of the slit. Width of the slit should be narrow. A wider slit can be treated as a number of narrow slits situated close to each other. Distance between the source and slit. A decrease in distance between the source and slit increases the intensity of the pattern and vice versa. Distance between slits. Smaller the distance between the source and slit, greater is the fringe width. Wavelength of the light. Greater the wavelength of the light, greater is the fringe width. One of the two slides is covered. In this case, light reaches the screen from one source only, so there will be no interference pattern. Whole of the screen shall be uniformly illuminated. One of the two slits is covered with a translucent paper. The amplitude of the light from two sources shall not be equal. This results in laser contrast between a dark fringe and the bright fringe. A translucent medium is introduced in one of the interfering beam. This makes the path difference between two beams different from the geometric path difference. The center C shall no longer be a point having a zero geometric path difference. This will result in shifting of the center of bright fringe to one side. The fringe with small shall remain unaffected. Changing of the medium all around. If whole of the apparatus is immersed in the water, wavelength of the light shall decrease than in the air. Since beta is equal to lambda, the fringe's width will decrease, or in other words, the pattern shall become narrow. Constructive interference. If the crease of one wave arrived at the same time as the crease of the other wave, then they are in phase. We call it as a constructive interference. Here the amplitude of the two waves add to form a larger amplitude. From the experiment, we can conclude that light travels in the form of a wave. If the light consists of tiny particles, we should only see two bright lines on the screen placed behind the slit, but instead a series of bright lines are seen in the screen. Hence, this proves that light travels in the form of wave and it undergoes interference and diffraction phenomenon.